Welcome on board. Before we begin, let's see how to use the navigational features for this course. The course title is displayed here. Click the 3 lines to view or hide the menu and audio transcript tab. Click the audio transcript tab to view the voice-over audio text. Note that pages without audio will display the text "No audio." The play-pause button allows you to play or pause the current page. Use the volume button to adjust the volume of the audio. Finally, use the previous and next buttons to view the previous or next page. Welcome to the Engine Resource Management, or ERM course. This course is designed to provide you with a comprehensive knowledge about the purpose and importance of ERM in maritime operations. This course will enable you to describe the ERM roles, understand manning levels, and effectively use ERM communication techniques. At the end of this course, you will be able to describe the purpose of ERM, describe ERM roles, explain manning levels, understand ERM's communication techniques, and identify practices enabling interventions. Let's get started. So, what is engine resource management? Engine resource management is an operational philosophy developed to avoid single-point failures when engine room operations are being conducted. It uses effective use of resources available to engine operations team, including communication, teamwork, and leadership. Let's do a brief activity to understand engine resource management better. In this activity, you will be presented with a short scenario. Based on this scenario, you will need to identify engine operations team roles and understand the key strategies to prevent failure. Here's the scenario background. Take a close look. Here's what happens after some time. To summarize, this exercise is a reminder to reinforce the importance of effective communication, teamwork, and leadership in ERM. It also emphasizes how role-based organization and shared mental models help prevent single-point failures. ERM is assisted by a role-based engine room organization. The role-based organization, as opposed to the traditional rank-based organization, ensures functional redundancy and empowers team members to operate and speak up regardless of their rank. This philosophy encourages the chief engineer to delegate operational tasks and assume a supervisory role, enhancing learning, participation, motivation, safety, and efficiency. Let us now take a look at the different roles who are present in the engine control room. Click the markers to learn more about who is supposed to be where in the ECR. Let's now move on to charge and control. The chief engineer has the overall responsibility for the safe operation of the engine room, but the officer with the charge is responsible for the safe and efficient operation of the ship's engine plant while protecting the environment. Note that having the charge is not the same as having the control. The control refers to operational control, which must be formally handed over with a clear announcement, "I have the control." In urgent situations, the operations director with the charge can take control. However, the position of the operations director should be re-established as soon as possible. Now let's find out about the responsibilities of the operator and the cooperator. The operator, who has the control, is required to communicate intentions and orders to the cooperator. Ideally, no machinery space operations are executed without being checked and agreed by the cooperator. The operator is responsible for operating the ship's machinery safely, following approved procedures. The operator also monitors and cross-checks the ship's technical plant through the monitoring system and is always located in the engine control room and retains the control to perform their responsibilities from the engine control room. The cooperator monitors and cross-checks the operator's action, supports and challenges the operator as needed, and is responsible for external VHF and ECR liaison, unless directed otherwise. Next, we will look at the responsibilities of the engine room watch rating. The engine room watch rating provides task feedback to the operator, co-operator, and assistant operator. Let's go ahead and practice how the engine room watch rating responds in the machinery space. Next, we will look at the responsibilities of the assistant operator. The assistant operator supports and performs the designated responsibilities of the operator and/or co-operator as required. They may move between the ECR and the machinery space depending of the operation being conducted. They can also support and challenge the actions of the rest of the engine operations team if they deviate from the intended plan. Finally, we will look at the responsibilities of the operations director and administrator. The operations director oversees the entire engine room operation, ensuring compliance with procedures, providing guidance, and monitoring the engine operations team. They manage the workload and conduct pre-operation briefings, ensuring safe execution of operations by the team. The administrator is an optional function that may be added in red manning at the discretion of the operations director. Their tasks may include managing external communications, updating the status board, and note-taking are required. Moving on, let's find out the importance of effective communication. Effective communication is critical in the engine room. Techniques such as closed-loop communication help ensure clarity and understanding among engine operations team members. This involves repeating orders and confirming with a yes to avoid misunderstandings. Let's take a look at closed-loop communication. Closed-loop communication takes place between two persons, the sender and the receiver. When the sender gives the order, the receiver must repeat the order. If the repeated order is correct, the sender must confirm with a yes and check the outcome. If the receiver repeats the order incorrectly, the sender must say negative and then repeat the correct order. If the sender does not get a reply, they must state, I say again. If the receiver does not get a yes from the sender, they must state, say again, until they get a yes. Along with closed-loop communication, we also need to know the importance of thinking aloud. Thinking aloud involves verbalizing thoughts, plans, and intentions to share the mental model with the engine operations team. The plan-reason-outcome, or PRO technique, helps others understand the intended actions and fosters a collaborative environment. Here's an example of the plan-reason-outcome technique, where the plan is verbalized before the action is initiated. The technique shows the intended action, the reason behind it, and the expected outcome. Challenging operational decisions is essential for safety. The PACE process provides a structured method for expressing concerns and ensuring that actions align with the intended plan. Let's go ahead and take a detailed look at this process. The PACE process stands for Probe, Alert, Challenge, and Emergency. Click the boxes to view what each of these means. Here's a scenario that shows the application of the PACE process. Please go through the scenario and proceed to the next page to see how the process is applied. Click the process titles to view how the PACE process is applied in this conversation. Note that regardless of the PACE process, the engine operations team must call the chief engineer if in any doubt. Even if the chief engineer has been called, the team must not hesitate to take immediate action for the safety of the ship, given the required circumstances. Moving on, let's take a look at manning levels. Manning levels are established in the engine control room to cope with the workload and complexity of the operations. There are 3 types of manning levels: green, yellow, and red. Let's take a close look at these levels. Click the icons to learn more about each manning level. Here's a quick snapshot of the required functions for all engine control room manning levels. Take a close look. So, when and how do we change manning levels? Transitioning between manning levels involves incoming team members gaining complete awareness of the situation and conducting team briefings. The officer in charge can increase the manning level based on changing conditions and must notify the chief engineer if this is an unplanned manning level change. Now let's take a look at how to transition from green or yellow to red manning. Let's do a quick activity on choosing the appropriate manning level. Here's a quick summary of the key points from the topics that we covered in this module. Please go through them carefully before moving on. Now that we are at the end of the course, it's time to reflect. Think about the answers to these questions, and we can discuss them when we meet in the classroom.